Hello, everyone. Welcome to video 3.3. We're going to be talking about deductive reasoning today, beginning on page 171. Our two lesson goals for today are number one, to apply the law of detachment to determine the validity of conclusions, and number two, to apply the law of syllogism to make valid conclusions from given statements. So the logic that we first turned to in this module, module 3, started with inductive reasoning. So here on page 171, as we talk about the law of detachment, you need to understand that it's unlike inductive reasoning, which of course uses a pattern of examples or observations to make a general conclusion. That's not how deductive reasoning works. Deductive reasoning uses general facts, rules, definitions, or properties to reach specific valid conclusions from given statements. An argument is valid if it's impossible for all the premises or supporting statements of the argument to be true and for its conclusion to be false. So deductive reasoning is one of those things that is popular in a lot of television shows, thinking of shows like Sherlock Holmes, Monk, House, all of the criminal scene investigation, NCIS, CSI, only murders in the building. All of these things use deductive reasoning. Our law of detachment is able to be symbolized in words, and also we have an example that goes with those symbols. So we have if P arrow to Q, if P then Q is a true statement, and P is true, then Q is true. So an example, if a car is out of gas, then it will not start. We have Sarah's car is out of gas, so the valid conclusion is Sarah's car will not start. Sometimes you hear the Latin phrase ergo, spelled E-R-G-O. It's a word that means the conclusion being, and then whatever your conclusion is follows. So here in example one, we're asked to determine whether each of these conclusions is based on inductive or deductive reasoning. Remember, inductive is due to patterns, deductive reasoning is due to facts that lead to conclusions. So part A, it says if a student is late returning a library book, then he or she will be charged a $2 late fee. Cheng returned a library book late, so he concludes that he will be charged a $2 late fee. And Chang is basing his conclusion on the library's policies. That would be the emphasis there. A policy is another name for a fact or a premise or a rule. And so he is using deductive reasoning. In example one, part B, we have every time Tamika has worn her favorite jersey to a football game, her school's team has won the game. Tamika is wearing her favorite jersey to the football game tonight, so she concludes that her school's team will win the game. Now, Tamika is basing this conclusion on a specific pattern of observations, so she's using inductive reasoning. Take a pause on the video here for this check after example one, and you're going to again determine whether each conclusion is based on inductive or deductive reasoning from the scenario that's presented to you. Next, we're going to explore whether the law of detachment applies so that we can determine whether conclusions are valid based on given information. So we have a scenario A talking about a field trip and scenario B talking about squares and polygons. And we're going to go ahead and explore these one at a time. So scenario A is saying, given to go on the field trip, a student must turn in a permission slip, and Mariana turned in her permission slip. What our conclusion is that Mariana can go on the field trip. We want to know if this is a valid conclusion or not. So step one says if I can identify a hypothesis and a conclusion. So it says because a student must turn in a permission slip to go on the field trip, that phrase, a student must turn in a permission slip, is the hypothesis, right? What has to be true first, hypothesis of the conditional statement. So you see in our orange P statement, a student turns in a permission slip. Q, the student can go on the field trip, breaking this into hypothesis and conclusion. Step 2 is asking us to analyze the conclusion. So the given statement, Mariana turned in her permission slip, does satisfy the hypothesis, so P is true. And by the law of detachment, Mariana can go on the field trip, which is matching our Q, our conclusion. And so that is a valid conclusion. Now we'll go to statement B. Given a figure is a square, then it is a polygon. Figure A is a polygon. And the conclusion is figure A is a square. Is this a valid or an invalid conclusion? Step 1 says identify the hypothesis and the conclusion. Of course, we know the hypothesis follows the if. So a figure is a square, and the conclusion follows the then. It is a polygon. Now we will analyze what conclusion we made and whether it's valid or not. The given statement figure A is a polygon does satisfy a part of the statement, but it satisfies the conclusion of a true conditional. However, knowing that a conditional statement and its conclusion are true does not make the hypothesis true. It's kind of the reverse, right, of the law of detachment. We have to go the other direction. Figure A could possibly, of course, be any other figure for it to be a polygon. It does not have to be a square. So this is an invalid conclusion. And that last sentence, of course, is coming up with a counter example to prove the conclusion false. Take a pause on the video here as we check on your use of the law of detachment in a couple of scenarios. Scenario A is given if 3 points are non-collinear, then they determine a plane. Points A, B, and C lie in plane G. Therefore, points A, B, and C are non-collinear. And then we have 4 choices of valid or invalid with accompanying logic that to choose from here. And then our next statement. Given if Dakota goes to the video game store, then he will buy a new game. Dakota went to the video game store this afternoon. Conclusion, Dakota bought a new game. And again, we have choices of valid or invalid with accompanying logic. The next law that's related to deductive reasoning is the law of syllogism. And what this law allows us to do is to draw conclusions from 2 true conditional statements when the conclusion of one statement is the hypothesis of the other. So we have here, again, in words and symbols here, our law of syllogism. If P, then Q, and Q, then R are true statements, then we can kind of loop from one to the other, from the front to the back of those statements. So then P, then R is a true statement. Here we have an example that hopefully will give you that connecting tissue in words a little bit better. So given if you get a job, then you will earn money. And if you earn money, then you will buy a car. The valid conclusion is if you get a job, then you will buy a car. And for those that are seeing these colors, hopefully you can see if P, then Q, and then this is our connector to the next statement. If Q, then R, we can go from P to R in one conclusion. Law of syllogism. So here in example 3, we have the law of syllogism happening with some sleep science here. Says scientists have found that the quality and amount of sleep greatly impact learning and memory. Lack of sleep causes students to have trouble focusing and receiving new information, and sleep deprivation also makes it difficult to retrieve previously learned information. So we're going to draw a valid conclusion from these given statements. If we summarize all of that and say, if you are tired, then you will not do well on your test. And if you do not get enough sleep, then you will be tired. Can we see a link between these statements? I hope you can agree we can with the tired part. And so the question is this a use of the law of syllogism, and how? So the order doesn't so much matter how it's presented to us, but if we can conclude that the conclusion of one statement is the hypothesis of the other statement, then we can link them with the law of syllogism. So given you are tired, then you will not do well on your test. And if you don't get enough sleep, then you will be tired. We again see that link of the tired part of the statement. And so we're going to reorder them so that the conclusion of the first statement leads into the hypothesis of the second. You can see this is really just the same two statements here in reversed order, and that's going to allow us to link them together. So if you do not get enough sleep, then you will be tired. And then if you are tired, you will not do well on your test. So we should be able to cut out the middleman and go one from one to the other. Notice they've again given us P, then Q, and then Q, then R. Breaking up our symbols, we can see statement one is P, then Q, statement two, Q, then R. And because both of those statements are true, and the conclusion of the first statement leads into the hypothesis of the second, the law of syllogism allows us to say if you do not get enough sleep, then you will not do well on your test. So here in example 3, we're going to check on our law of syllogism with a statement about the Grand Canyon, couple of statements about the Grand Canyon. So take a pause on the video and see if the law of syllogism can be used here.
Okay, everyone, this is the part of the video where you really want to check back on the answers to those checks that were assigned to you as you were watching.
All right, back on page 172 here with our check for example 1. And we are determining whether each conclusion is based on inductive or deductive reasoning. So our first example, part A, has Newton's first law of motion states that an object at rest will remain at rest unless acted upon by an unbalanced force. Elisa watches a soccer ball roll across the field, and she concludes that an unbalanced force has acted upon the soccer ball. So hopefully you were drawn to the word law there. In statement B, Mrs. Jackson notices that her family's data usage is increasing by approximately 2,500 megabytes of data every month. So she concludes that her family's data usage next month will be 2,500 megabytes greater than this month. And so she's looking at the every month pattern there. So we should have come up with in part A that this is deductive reasoning. It's based on that law of motion. And that Mrs. Jackson's conclusion is inductive based on the pattern that she has seen in her family's data usage over time. For the check after example 2, at the top of page 173, our goal was to determine whether the conclusion was valid or invalid and what are the supporting logical statements that justify that. So if 3 points are non-collinear, then they determine a plane. Points A, B, and C lie in plane G. If you'll notice, the law of detachment has to do with if the first part is true, then the second part is true. And points A, B, and C was not referring to them being non-collinear. So we have two choices. Obviously, it is an invalid conclusion. Is it choice C? Invalid points A, B, and C determine a plane G, and therefore they are non-collinear? Or do we only know that points A, B, and C lie in plane G? So they could be collinear, and that is certainly true. And so we are at choice D there. Our second part of our check for example 2 is asking here if Dakota goes to the video game store, then he will buy a new game. Dakota went to the video game store this afternoon. The conclusion is Dakota bought a new game. Is this a valid or an invalid conclusion, and why or why not? So we're looking here at, we're seeing if P then Q. We definitely have the statement of the conclusion coming from Q. So this is a valid statement. The question is, what is the supporting logic? So for part or choice B, we have valid because the statement Dakota went to the video game store this afternoon satisfies the conclusion of the conditional statement. The hypothesis is true. Or choice C, valid because the statement Dakota went to the video game store this afternoon satisfies the hypothesis. And of course, we know it's the hypothesis, right? If P, then Q. So P is true, therefore Q is true. And so we have C is our reasoning behind valid. Now with our final check on page 174, we're asked to use the law of syllogism to draw a valid conclusion if possible. Our given statements are if Ebony takes a vacation, then she will go to the Grand Canyon. And if Ebony goes to the Grand Canyon, then she will hike to the Colorado River. Hopefully you can see that our conclusion should be, because we have P here, and then Q is the Grand Canyon part, and then we start off the next statement with Q, and then R being the hike. So our conclusion is going to be if P, then R. So putting words to that, if Ebony takes a vacation, and we'll skip to the R part, then she will hike the Colorado River. And that's how we have our two laws for deductive reasoning today. We'll see you in the practice.